Before we proceed any further, let's have some clarification concerning fire blocking. People in the building industry believe that these two terms are interchangeable, fire blocking, fire stopping, or they both mean the same thing. However, their use and their purpose is very different. Per the IBC, the difference between fire stopping and fire blocking or draft stopping. Section 714, Penetration Fire Stop, identifies that penetration fire stop protects penetrations into rated assemblies. It applies to both combustible and non-combustible construction, and typically it is a tested system. Section 718, Fire Blocking or Draft Stopping, limits spread of fire within concealed spaces, may be rated or non-rated, typically in combustible construction, and not tested. Fire block and draft stop are both addressed in the International Building Code. Fire block is a material whose main purpose is to slow air oxygen from feeding a fire and to resist free passage of flames or other products of combustion to other areas throughout concealed spaces. It is required by code to be used in concealed locations of combustible construction to prevent fire from quickly spreading through these spaces. Such material will, as an inherent characteristic, also slow the migration of smoke throughout the building. Fire blocking and draft stopping are fire safety items specifically tied to the use in wood framing. They have similar purposes. Fire blocking is intended to resist the movement of flames. Draft stopping is intended to resist the passage of smoke and gases. These materials that are used are not tested as part of an assembly. Refer to the International Building Code, Section 718. True or false? There is no difference between fire stop and fire block. Penetrations of fire-resistive assemblies are addressed in Section 714 of the International Building Code. Through penetrations shall be protected by an approved penetration fire stop system installed as tested in accordance with ASTM E814 or UL 1479. The key phrase here is installed as tested. The installed system shall exactly match the UL system as it was tested. A through penetration fire stop system consists of a fire rated wall or floor, a penetrating item, pipe, cable, conduits, etc., and the fire stop sealant. For rated systems, the complete fire stop system is tested and listed, not just the fire stop sealant alone. Fire stop materials are not fire rated. The system in which they are installed carries the rating. Membrane penetrations. Membrane penetration shall comply with Section 714.4.1. Where walls or partitions are required to have a fire resistance rating, recessed fixtures shall be installed such that the required fire resistance rating will not be reduced. Joints installed in or between fire resistance rated walls, floors or floor ceiling assemblies, and roofs or roof ceiling assemblies shall be protected by an approved fire resistant joint system designed to resist the passage of fire for a time period not less than the required fire resistance rating of the wall, floor, or roof in or between which the system is installed. Fire resistant joint systems shall be tested in accordance with Section 715.3. The void created at the intersection of a floor ceiling assembly and an exterior curtain wall assembly shall be protected in accordance with 715.3. Fire resistant joint systems shall be securely installed in or on the joint for its entire length so as not to dislodge, loosen, or otherwise impair its ability to accommodate expected building movements and to resist the passage of fire and hot gases. Where fire resistance rated floor or floor ceiling assemblies are required, voids created at the intersection of the exterior curtain wall assemblies and such floor assemblies shall be sealed with an approved material or system to prevent the interior spread of fire. Joint systems shall be tested in accordance with the requirements of either ASTM E1966 or UL 2079. Before we go any further, let's have some curtain wall basics. What we're going to be discussing here is your multi-story buildings. where the slab goes just shy of the outside curtain wall. The curtain wall has its own support mechanism. We have this gap that exists from the edge of the slab to the curtain wall. This can be 1/8 of an inch, it could be 6 or 8 inches. Depends on the building and its design. What we're trying to prevent is the flow of fire or smoke from a story below to the story above through this opening that is created. Therefore, mineral wool is the most typical application to fill this gap, along with another application, which is all part of UL design assembly. The UL design for this curtain wall application needs to be followed exactly. Typically what I see is mineral wool application is incorrectly applied. Mineral wool typically will be listed as a certain compression. It is also listed as how it should be applied and the orientation of the grain of the mineral wool. Each of these items needs to be closely examined when you're conducting your field inspection. Let's have another quiz. Through penetration shall be protected by an approved Firestop system. A, approved by the design professional. B, approved by the manufacturer. C, installed as drawn. Or D, installed as tested. Beginning with the 2012 edition of the International Building Code, special inspection of Firestop systems, fire-resistant joint systems, and perimeter fire containment systems installed in high-rise buildings and buildings defined as risk category 3 or 4 were required. The proper installation of these critical life-safety systems help protect the building and its occupants against the spread of fire, heat, smoke, and toxic gases should an event occur. Chapter 17 of the International Building Code provides a variety of procedures and criteria for testing materials and assemblies and labeling materials and assemblies. Its key purpose is to establish where additional inspections, observations, and testing must be provided, and the submittals and verifications that must be provided to the building official. Chapter 17 expands on the inspections of Chapter 1 by requiring special inspections by a qualified individual where indicated, and in some cases structural observations by a registered design professional. Quality assurance measures that verify proper assembly of structural components and the suitability of the installed materials are intended to provide a building that, once constructed, complies with the minimum structural and fire resistance code requirements as well as the approved design. In addition to requiring special inspection of Firestop systems, the inspection process is also clearly defined, referencing ASTM E2174 and ASTM E2393. ASTM E2174, Standard Practice for On-Site Inspection of Installed Fire Stops. This lists very specific requirements for sampling, verifying materials prior to installation, verifying that EJs are not being used when there are listed systems available, verify that all Firestop systems have been completely installed, verifications for each type of Firestop, and witnessing 10% of installations or destructive testing of 2% of similar installations. The IBC also specifically lists ASTM E2393, Standard Practice for on-site inspection of installed fire-resistive joints and perimeter fire barriers. There are some specific requirements here. Typical types of inspections include head of wall, bottom of wall, slab edge, drywall to columns or beams, and dissimilar materials. The requirement for third-party special inspection is not going to mean that every project needs this level of scrutiny. The building code clearly relegates this to 3 types of buildings: high-rise buildings and buildings in risk category 3 or risk category 4. First, the term high-rise conjures up a mental image to most people, but let's be clear about what the term actually means. A high-rise structure is defined by the code as a building with an occupied floor located more than 75 feet above the lowest level of the fire department vehicle access. This means that you can take the same building and put it in a different jurisdiction, and based on the firefighting equipment, it will be considered a high-rise structure in one jurisdiction, but not in another. Shown is Table 1604.5 from the 2018 IBC. The building code defines occupant load as the number of persons for which a means of egress of a building or portion of a building is designed. The occupancy load will vary based on the use of the building, but also because of the familiarity and the agility of the occupants. For example, people who may be in a public assembly building are less likely to be familiar with the various ways to enter and exit the building, as compared to the people who might be in a building for adult education. And while the occupants of an elementary or secondary school are likely to be familiar with the building, they are less likely to be expected to exit the building safely upon an emergency. Additionally, occupants of Group I-2 hospital are likely going to need assistance to evacuate a building, and it's very likely you don't want occupants of an I-3, a jail, that type structure, being able to freely evacuate a building. If there is a fire in any of these types of buildings, you can see that there is a substantial hazard to human life in the event of failure. Category 3 is defined by the code as structures that represent a substantial hazard to human life in the event of a failure. This means that because they are buildings that are important to the community, they should be protected with an extra level of protection that is provided by this requirement for special inspection of Firestop. Category 3 buildings include public assembly buildings with an occupancy load over 300, elementary or secondary school or daycare with an occupancy over 250, adult education with occupancy over 500, Groups I-2 with occupancy over 50 without surgery or emergency procedures. Category 4 buildings are buildings and other structures designated as essential facilities. The difference between risk category 3 and 4 is that type 4 buildings are considered essential to the community in which they serve. Schools in a community are essential to that community, but in the event of a fire, the children can still be educated in a different setting until the school is repaired. However, if that same school were designated as an emergency shelter, then it would fall into risk category 4 because now it is considered essential to the community. When reviewing submittals, the plans examiner should be cautious concerning the addition of the statement of special inspections that's being used. Some of the older forms do not have a listing for special inspection for Firestop. This covers where third-party special inspection is mandated by the building code. That said, however, a jurisdiction can still require a third-party special inspection of Firestop on any project where they feel they have a shortfall in either manpower or expertise. This even can be done in a jurisdiction which might be on an earlier code edition. True or false? Penetration Firestop is required to have special inspection for Category 2 facilities. So fill in the blanks. How do we address the intersection created at a fire barrier and a non-fire rated assembly? When is an engineering judgment typically not acceptable? So this is going to conclude this section of the training on Firestop. Remember, there were 5 different sessions. I ask that you go through each one. Also, be sure to like and subscribe to this YouTube video. We appreciate that. It helps us along the way. And if there's any questions you got, email me. My email's showing up here on the screen for you. Reach out to us anytime, dolesmichael@gmail.com. We're in South Carolina. If we're in an area that we could come and visit with you or your group, we'll be glad to do that. So just sit back and go through all the videos. Try to glean as much information as you can. And again, this is, pretty much just my experience and my opinions on some things. We'll give you some really good references. And I wish you the very best with everything you're doing.